Let us solve this question by using Kirchhoff's law. You just consider the circuit. Here first we have to apply junction rule at the junction D. At junction D, I1 and I2 are the current flowing away from the junction and I3 is the current flowing towards the junction. So that we can write I3 which is equal to I1 plus I2. Can take this is equation number 1. Then we have to apply Kirchhoff voltage rule. For that first we have to take the loop D, C, F, E, D. Here first we have to consider the region D to C. Here the potential difference across the resistor 40 ohm is 40 into I3. Here we are using positive sign. The reason is we are moving low potential to high potential. And next you just consider the cell. Here this is the positive terminal and here it is the negative end. So that the potential difference across the cell is 40 volt. Next, C to F there is no resistor and we can consider F to E. Here the current flowing through the resistor is I1 and the resistance value is 20. Therefore, the potential difference across the 20 ohm resistor is plus 20 into I1 which is equal to 0. The next we have to write 40 I3 plus 20 I1 which is equal to 40. Then we can take 20 as common. You will get 2 I3 plus I1 which is equal to 40. Then you can apply the value of I3. So you get 2 into I1 plus I2 plus I1 which is equal to 40 by 20. Then 2 I1 plus 2 I2 plus I1 which is equal to 2. So 2 I1 plus I1, you will get the equation 3 I1 plus 2 I2 which is equal to 2. Can take this is equation number 2. Then we can consider the loop A, B, F, E, A. So here you first consider the region A to B. Here the current is I2 but here the cell, here it is negative terminal, here it is positive terminal. So you can take the value 80, next minus 20 into I2, the next B to F no resistor, F to E you will get the value plus 20 I1 which is equal to 0. The same equation we can write 20 I1 minus 20 I2 which is equal to minus 80. Then we can take 20 as common. We will get I1 minus I2 is equal to minus 80. Therefore, I1 minus I2 which is equal to minus 80 by 20. Then we can get I1 minus I2 which is equal to minus 4. This is equation number 3. Then we can solve equation 2 and 3. The second equation is 3I1 plus 2I2 which is equal to 2. Multiply equation 3 by 2. This implies 2I1 minus 2I2 which is equal to minus 8. When we solve this equation, here plus 2I2 and minus 2I2 cancel. 3I1 plus 2I1 which is 5I1 which is equal to 2 minus 8, you will get the value minus 6. Therefore, I1 is equal to minus 6 by 5. So, you will get the value, it is nearly equal to minus 1.2 ampere. In the question, we have to calculate only the value of current I1.
If you found this video helpful, please like, share and subscribe to the channel. See you in next class.